Hey everybody, so in this video I'm going to be going in a little bit detail about these two special logic gates, XOR, sometimes pronounced exclusive OR, and this one XNOR. So that's the symbol for the XOR, plus with the circle around, and this is the logic gate symbol used in a digital circuit. So the truth table, all right, the truth table, you see when you have two zeros as your input, your output is 0. When you have two inputs as 1, your output is also 0. But when you have a mix of the two, a 0 and a 1 or a 1 and a 0, your output is going to be 1. So a good way to remember the truth table for the XOR is if you have two inputs as the same kind, whether it's a 0 or 1, your output is going to be 0. And if they're mixed, then your output is going to be 1. And XNOR is pretty much the complement of XOR, so we're pretty much going to take the complement of the output. If you have a 0, the XNOR is going to be 1. If you have a 1, the XNOR is going to be 0. So it's pretty much complementing the XOR. Therefore, a good expression to remember is that the XNOR, sometimes this is the symbol for XNOR, which is also the symbol for equivalence. So you could see XNOR and the expression equivalence used interchangeably, especially in digital circuits. So if you have, the XNOR, that is equal to the complement of the XOR. So you could apply De Morgan's law, and you would end up getting the expression for XNOR. So I have right here if you wanna summarize what XOR is, it's pretty much x prime y plus xy prime. And then for XNOR, it's xy plus, this is a prime, plus x prime y prime. Right? Okay, so xy plus x prime y prime. So I have this example, we're going to simplify it. So using this formula for the XOR, we're pretty much gonna, let's say this is A and this is B. The XOR tells us, if we have A XOR B, tells us that we're gonna take the complement of A and it with B, and then we're gonna add it A and the complement of B. So substituting A and B for their original expressions, we get xy prime times xz plus xy and xz and the complement of that. Okay, let me zoom in a little. So now we're just going to do some De Morgan's law simplification. So this would break down to x prime plus y prime, and then we have xz plus xy, and then this would break down into x prime plus z prime. So now I'm just going to distribute, and so I get x prime xz plus xz y prime plus x prime y plus x y z prime. All right, so we know from the rules of Boolean algebra, x and x prime is 0, and then 0 and anything, in this case z, is 0. So this is 0. This would then also be 0. And so we're left with x z y prime plus x y z prime. Okay, and you could leave it, you could simplify by factoring out the x. So you would have then x z y prime, and then plus y z prime, And you could take it a step further and simplify even more. That would then be zy prime plus y, and then zy prime plus z prime. And then you could simplify that the same way again, and that would be y plus y prime, y plus z, and then z prime plus z, and then z prime plus y prime. These simplify to 1. Okay. Anything ORed with its prime is 1. Okay, so then if you just rewrite what we have left, we have x, and then y plus z, and then z prime plus y prime. Okay, we could go ahead and distribute these, FOIL it, and then you would have, see, we have x outside. Okay, let me make some space. Alright, so you have x outside, and then, alright, so y, we're going to distribute, FOIL pretty much. So y z prime, and then we have y times y prime, so that's y and y prime, which is 0. So I'm just going to skip it. And then z and z prime, that's also 0. And then we have z and y prime. And that's pretty much it. You can't go any further. Or maybe you can. Let's see, then that would be x. And then you would have yz prime plus z. And then yz prime plus y prime. Alright, and then that would simplify to x, and then y plus z, z plus z prime, and then y prime plus y, and then y prime plus z prime. These simplify to 1. And then so you're just left with, okay, I mean, I think we're just going in cycles. That would just have this, that, all multiplied together would be your pretty much simplified version.